Okay, compound interest. Imagine you go to Build Society, put in £10,000 and you leave it there for 5 years. If you don't withdraw any of the interest payments, not that it's very good nowadays, you just leave it there and it will accumulate bit by bit by bit. So after 1 year you get one blob of interest, that gets added onto your £10,000. So you've got £10,000 plus a little bit more. Then they work out your interest rate at the end of the next year. Then you get a little bit more, not just of the £10,000, but of the £10,000 originally invested, plus the interest gained from the previous year. So it compounds and builds up. You can do calculations like this, showing every single step of the calculation, but if you're leaving it there for say 10 years, you're going to show at least 10 steps in the calculation, and there's got to be a smarter way to do it than that. And I hinted at it on a previous video. Now let's just jump straight in on page 52, compound interest. I want to do a starter question. Question 4 on page 52. What is the compound interest on £16,000? £16,000 invested for 4 years at 5.75%. So I'm going to multiply by 1.0575. Okay, so that little part there means 5.75%, 5.75. But since I'm not going to take it out, I'm going to put it into the original £16,000 invested, and I will now see how much I'll get after 1 year if I press the equals button. Now I'm not going to press equals just yet because I'm going to leave it there for 4 years. So I'm going to multiply £16,000 by that, and then by that again, and then by that again, and then by that again. So imagine 4 of these all in a line here, going multiply, 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 multiply. Don't need to write it out. Let's be smart. This is grade B. I'm going to leave it there for 4 years. I've got 4 of these multiplied together, one after the other. Just call it a power of 4. Now we're going to pick up our calculator and get it in one go the smart way, rather than doing 4 separate steps or whatever. So how do you use this machine? Right, there it is. I'm going to go 16,000 multiplied by 1.0575. That's my 105.75%, and I'm going to power that up to 4. I have now got in my bank account, and this is very, very nice, £20,009.74. Now that's how much is in the account. I didn't earn all of that, I earned the difference, so therefore I've got £20,009.74. Take away the original 16,000 that I put in. I can see I've earned myself £4,009.74, and I didn't even use my calculator. Is that alright? So that is the compound interest on top of the 16,000 that I put in originally, and that's question 4 as a starter. Now question 5. This is Carmen talking now. Now Carmen's deal is that she's putting in 2,500 into the, where is she going to put it? She's going to invest it in savings account, okay, and is going to pay 4%, you wish. She says that after 5 years she will have 20% more. Well, let's have a look. We need to multiply by 1.04, and that's going to be over 5 years. Save me writing this out 5 times. Let's get the answer in one step, and that'll be great. 2500 multiplied by 1.04 powered up to 5 years. Right, equals. So Carmen will have, after 5 years, if she doesn't take any interest out, £3,041.63. It's nearest penny. It's what she's got there after 5 years. And Carmen says, I'll have 20% more than I put in. Let's just work it out, shall we? Now, percentage difference, percentage increase. Well, that's the difference. Okay, that's how much compound interest you would have made over the original money. Multiply that by 100. The final answer to that is by 100, and we'll see if Carmen made her 20% or got more than 20%. So here we go. Let's get the difference first. 3041 spot 63. Take away her original 2,500. Press equals. Divide that by 2,500. So that was the original. And Carmen's actually got 21.7%. She's actually got more than she bargained for. So well done, Carmen. So therefore she's wrong. So let's get in a mark. Therefore Carmen is wrong. Alright? Because she was calculating 20% mentally. Alright, that's Carmen sorted. I've also got question 6 here. I should have really pasted this onto the background, but it's a lovely question. I've got two things here. Roy wants to invest £5,000 for 3 years, and he's looking at 2 accounts. So he's now got the simple saver. Let's see if Roy's a simple saver. He's going to get 4.6% as a simple saver. Then he can take out his interest at the end of each year. And the compound saver, the option is to go for 4.6%, and you add the interest on at the end of each year. Now I like this question because we can see the difference between taking out the interest every year and leaving it there for year on year. Just see what the difference is going to be. Work out how much interest Roy will get if he uses the compound saver. Well, I want to do both actually. Let's do the simple saver first. He's going to invest £5,000 at 4.6%, which is 0.4. Sorry, let's just rub it out. 0.046. 04. That's 4%, and that's the 0.6. All right, and he's going to leave it in there for how long? Take it out after every year. So he's going to do this for 3 years. All right. So £5,000, 4% each year. He takes it out. But he's going to do it for 3 years. Let's see how much interest he gains. So £5,000 multiplied by 0.046, that's the interest rate, multiplied by 3 lots of years, he keeps taking it out. Now Roy has earned £690 using the simple interest method, and it doesn't ask you to do that, but it's really interesting to compare how much you get by simple interest, how much you get if you compound it. Now let's do the compound interest method. £5,000 invested, 1.046 to the power of 3 for 3 years. Let's work this out. So £5,000 multiplied by 1.046 powered up to 3 years, I believe. Yes. And in his account, Roy has, now don't be put off by this just yet, 5722 and some pennies. It's the nearest penny. That's not all winnings. That is the interest plus the original £5,000. Therefore, the difference is going to be, which is compound interest actually, is going to be that minus the original 5,000. We can all see that £722 and 22p. Now look, Roy put in the same amount, and instead of taking out his interest every year and ending up with £690, he left it there and got £722 and 22 pence, which is a little bit more. Now, big deal, you might say, okay, I get that, but what if it was £50,000? Then obviously the compound return he would get is considerably more than had he just left it there and then taken it out every year and got greedy. So there we go, that's the power of compound interest. I want to stop there to give you a chance to think about it, and there will be 3 more questions I believe later on. I can't really tell how long I've been on this video. Maybe I should try it now while I'm on a roll. Question 6 is done. Question 9. Let's go for it and see what happens. Question 9 says £8,000 invested at 5.5% compound interest. The interest is added at the end of each year. Show that it takes 5 years for the amount to grow more than £10,000. Well, I'm refusing to do 5 years of calculations, but since they say it's going to take 5 years, let's try and prove it, shall we? £8,000 invested at 5.5%, so it's 1.055. There's the 5.5% there, and it's to stay there for 5 years. Now let's see if we beat the £10,000 mark. All we have to do is press equals and see if it works. It says show that it takes 5 years for the amount to grow to more than that. Well, let's see what happens. £8,000 multiplied by 1.055 powered up to 5 years, I believe it says. Yes, it does. Yes, congratulations us. £10,455, and to the nearest penny that's 68p. There you go, we've proven it. Now this is GCSE, but I refuse to accept that they want us to do 5 of these calculations all in a line just to show it gradually increasing, where we're working smart at grade B, putting the power of 5 there and being done with it. And that's question 9. Next one, question 12. Very interesting question. Although this is compound interest, here we have a compound type question, but it doesn't involve money. It involves a poor chap called Michael, who's obviously quite heavy. He wants to join a slimming club. He weighs 112 kilograms. His target weight is 80 kilograms. So this is Mike, a heavy dude apparently. So he's 112 now, and he wants to get down to 80 kilograms eventually. Now he aims to lose 3.5%, call it 3.5%. So he wants to drop 3.5% of his body weight every month. Show that it takes him 10 months to reach his target weight. Okay, well here I go. 112, not money, it's kilograms. To drop by 3.5%, you must still retain, what's that, 96.5% of your body weight. In other words, 0.965. There's the 96.5%, plus the 3.5% will make 100% body weight. So by dropping 3.5%, you are decreasing by 3.5% every single month. Now we're doing this for 10 months, so it's a power of 10. Hopefully that will drop below 80. Let's just take a look at that. Alright, you just study this now. I went from there to there, alright? It's a bit like a multiplier in a way. So here I go, 112. That's the weight times 0.965 powered up to 10 equals, he's done it, it's 78.43 kilograms. We have proved it would take Mike 10 months to drop below his target weight of 80 kilograms, provided he drops his body weight by 3.5% month after month after month after month after month for 10 months. Okay, so essentially that's revision for compound interest. You can study these vids in your own time.